Okay, so let's talk about areas of regular polygons and circles. First of all, who can give me a definition of a polygon? How about a closed figure? Perfect. And a regular polygon? Not just five-sided, but what about the sides, James? They are the same measure. Good job. So let's say each side has the same measure. Okay, so let's look at this polygon. It's actually a regular polygon, which means that each one of these sides are the same. What else can we say about this polygon? Okay, we have a 90-degree angle here. Good. What did you say, Kayla? The angles are congruent as well as the sides. What do we call those angles, Kayla, that come from the center out? Central angles. So each one of these angles is a central angle, correct? And because they're central angles and they're opposite sides that also have the same measure, all of the angles, all the central angles also have the same measure, correct? So if all of these central angles have the same measure, can somebody tell me what this angle is? How would I find this angle? If they're all the same, well then what is it? Okay, James brought up a good point. James brought up the point, wouldn't it be the same as the side? Well, technically if we had a circle coming out like this, you're right, James, it would be, but you're talking about the arc would be the same. You're absolutely right. But not the side. The arc would be the same. But at the same time, we can also say that if there's 360 degrees in a circle, I could just break up 360 degrees by 5, and I could get this central angle right here. Correct? So far we know the central angle. Not only that, I know something else. If this is a central angle, and I know that this is equal to this, is equal to this, is equal to this, and this is a 90-degree angle, what do I know about this side? Melanie? It splits this, which also makes this angle 36. Good. So NPQ would equal 36. What I'm trying to say is we can see a lot just from this picture. Just by knowing that it is a regular polygon, or pentagon I should say, because that would make it 5 sides, it tells us a lot, more than we can just look at, right? We've learned quite a bit from it. Okay, so this is where it gets a little more abstract. This line right here, going from the center out to the side making a 90-degree angle, is called the apothem. And let's define the apothem. A segment from the center perpendicular to the side. And because it's perpendicular, we know it's a 90-degree angle, and that's how we know that it bisects that segment, correct? Okay, don't worry about writing any of this out. I'm just going to try and make a point with it. What I really want you to write out is what the area of a regular polygon is. So if you have a polygon and it says that it's a regular polygon, then the area is half the perimeter times the the opossum, which is very abstract, right? We have not seen this before. And that being said, there is a relationship between the opossum and the perimeter of any polygon. Let's look at these relationships. Let's say this circle is the same size. Each one of these circles is the same size. And I decide I'm going to shove in a polygon inside of the circle. Well, this one happens to be 3-sided, 5-sided, 8-sided, 10-sided, 20-sided, 50-sided, and so on and so forth. If I were to take the number of sides, which is 3, and multiply it by the measure of each side, what would that figure give me? What? Not the area, the perimeter, right? That would give me the perimeter all the way around this figure. And then if I multiply it by the opossum, I would get the area. Correct? That's what this formula right here tells me. The radius? Well, look back at this one. This would be the radius. Not only is it the radius of the polygon, because it goes from the center straight out to the vertices. See that? It also looks like the radius of a circle. That's why we call it R. That was a good question, Devin. I didn't cover that when I was talking about it. So yes, that would be R. Okay, so as we go through this, I'm not going to make you work these out. Here's the numbers that pop up. What do you think the next one's going to be? You don't need to write this down. I just want you to look at it. You don't need a calculator, Connor.
4.09.
No. Tammany's got it. Why? Why did you say that?
Because it's a circle and it's a
The area of a circle is pi r squared, right? And look at, isn't that what's happening here? As these figures look more and more and more and more like a circle, you're getting closer and closer and closer and closer to pi, which is pretty cool. Well, just about, right? As it goes closer and closer, it'd probably be 3.1415, you know, it's going to go closer and closer and closer and closer to pi. Okay, so what can we conclude about our calculations? That as this gets closer and closer and closer to a circle, we get the area of a circle is pi times the radius squared. That's what you need, which most of you already know that formula. I just want to show how it relates to the opossum. Okay, so now let's work with these two things. Write down this figure. Okay, so let's start with this one. What do we know based on this figure so far? We know all the sides are congruent because it's a regular polygon. True. We know that EF and SD are congruent. Good. We know that all the central angles are congruent. Do we know what the central angle is? What is it? We just found it on the last example, right? It's 72 because this is a pentagon. All right, let's stop there and let's go to what we're trying to find. We're trying to find the area of a regular pentagon. So what's our formula again for a regular pentagon? Half the perimeter times the opossum. Okay. So, it's a term you've never heard before, right? Okay. So let's work with this. We already know what the perimeter is. What is the perimeter? It tells us right here that our perimeter is 90 degrees. So now all I have to do is find the apothem. How do we find the apothem? Well, I've got a right triangle, correct? So let's draw the right triangle separate. Hold on. Draw myself a right triangle. I'm going to start labeling it. Don't I know what the sides are? Not the sides. It is 36 degrees, good. How can I find each one of these sides? Divide what? I heard it. Divide 90 by 5. I know that all the way around this figure is 90, so I know 90 divided by 5 is what? 18. So each side is 18. If each side is 18, then what's this side? 9. So I found this. What am I looking for? Where did I get 90 from? It's right here. They told us that our perimeter is 90 degrees. So I'm looking for the apothem, right? I'm looking for this. Does this look familiar? Say hello to your friend SOHCAHTOA. See, and I'm not going to get in a bad mood. So I was already anticipating that response. Okay, so SOHCAHTOA, which one do I need? I have an angle of 36. Opposite of 36 is 9, and what would we call this? The adjacent. So I need TOA. So I'm going to use tangent of what? 36 equals 9 over x. I'm going to multiply both sides by x, and I get x times the tangent of 36 equals 9. Then what do I do? Divide by tangent of 36. Oh, we're not done. Don't worry. As promised. These cancel out. And then I've got x equals, and I already worked it out for you, 12.4. That's the apothem. So now that I know the apothem, can't I find the area of that figure? Area equals half of 90 times 12.4, which equals 557 meters squared. All right, so let's look at another example. This one's even more complicated. Okay, it is and it isn't. So this time it says find the area of the shaded region. Well, I have two different figures here. I have the area of a circle, and I want to subtract the area of a triangle. Now, when you look at this example in the book, it's going to be done a different way. Okay? All right, so what's the area of a circle? We already know this. Pi r squared. We already know what the radius is. What is it? 7 squared, which is 49 pi. And if I put that in a calculator, I would get 154. That part's easy. But I'm not going to try and find the area of a triangle because the area of a triangle is base times height, correct? I don't have height. I don't have base. I don't have any of that stuff. I can get base and height by using triangles and using the apothem. The book tells you to find the opossum and then use it to find this little triangle right here, talk about this little triangle, and then look at the larger triangle and find that one, and then use base times height. Well, why would I do that when as soon as I find the opossum, I can use this formula here. The area of any regular polygon is what? Half times the perimeter times the opossum. So if I'm finding the opossum, why not just go straight to the formula? You know what I mean? But we're going to do it right now. Okay, so if this is 7, well, let's draw our triangle. So here's my triangle. I may not know the sides, but I do know the central angle. What's each central angle going to be? No, not one. Yes. 180. No. 360. But we're talking about the central angle, not these angles. We're talking about the central angle. Isn't there 360 degrees inside this circle right here? So if I take 360 and divide it by 3, I would get 120. So this whole angle right here is 120. Correct? If the whole angle is 120, what's this? 60. Ooh, look what I found. It's a 30, 60, 90 triangle. And if it's a 30, 60, 90 triangle, then this is the shorter side. If this is 7, what's this? 3.5. And if this is 3.5, what's this? 3.5 square root of 3. And if this is 3.5, the square root of 3, what's this whole base? 7 square root 3. Okay. So now I have the opossum, right? Isn't the opossum 3.5? And technically, don't I also have the whole perimeter too? Wouldn't it be just, what, 21 root 3? So find that in a calculator. What's the perimeter? Am I going too fast? I got 36.3. Okay. Okay, I'll stop. Let's back up 1 second. Okay, if this is a 30, where'd I get the 60? If this is 180 degrees right here, right? I'm sorry, 360 degrees. Then 360 degrees divided by 3 different central angles. Don't I have 3 central angles here? Then that's 120. If this is the opossum, then it splits. Not only does it bisect this angle, it also bisects this side, right? Correct? So that means that's 60. If this angle is 120, then this angle is 60. Got it? So since this angle is 60, I know I have a 30, 60, 90. If I know this is 7, I know that the smaller leg is half the size of the hypotenuse. If this is the smaller leg, then I know that the smaller leg can be multiplied by root 3, and I get the longer leg. If I know the longer leg is this, I just multiply it by 2, and that's the whole side. .5. Put this in a calculator. What's 3.5 root 3? I have 6.06. This side is 6.06. If this side is if the radicals confuse you, just use decimals. 6.06. If one side's 6.06, what's the whole thing? 12.12. If 12.12 is one side, what's the whole perimeter? 12.12 times 3, which is 36.36. So my perimeter is 36.36. Now don't I have enough? Now that's where the book takes it even further. They say, well, if I know that, then I can find this 30, 60, 90 triangle. They get the height and they have the base. Why go that far when we already know that the area of any polygon is going to be half the perimeter times the, I keep forgetting it, the apothem. So area equals half of my perimeter, which is 36.36, times my apothem, which is 3.5. I get that, and I have about 63.5. But we're not done yet. You guys subtract it. Right? We were trying to find the area of the shaded region. So 154 minus 63.5 equals a grand total of 90.5 centimeters squared for the area of the shaded region. And we're done.